Okay, hi everyone. Thanks for having me. Stuart's talk was really awesome, so it will be hard to follow up. I'm here to give you a slightly different perspective when your application depends on a lot of physical devices, but you don't have any control over them, and they're just something you have to use, but they're not essential for your application. So this is the agenda. I'll start by giving a little bit of context, what I'm calling an ancient world. And then the next three are kind of recipes to solve some of the problems we found. And the last one is a little bit beyond test automation. What else were we doing in terms of continuous delivery? So maybe some of you or the front ends at your companies, they work with this kind of JavaScript frameworks, React, and in the back end, maybe you're dealing with scalability issues and you're trying to find the best way to deal with that kind of things. But that's not everyone's working with those kind of latest technologies, and that's fine. There are a lot of other technical stacks and people working with legacy applications. And in this project I was working at until a year and a half ago, sometimes it felt like we were using this kind of tools, like really old-fashioned. And some of them made sense to use, and others was just because resistance to change and systems not designed for evolution. But that's what we had. So in terms of context, what were we doing? Well, this organization develops border control systems, document verification systems, and biometric data enrollment kind of systems. And why do desktop applications still make sense? In particular, these were Windows desktop applications. Well, for a few reasons. One, first, we depended on devices that provided very low-level SDKs. Most were written in C. If you were lucky, you'd get the C++ one. Also, in a border control kind of system, the bottleneck is not how many server instances you have or containers. The bottleneck are how many immigration officers are working at the same time. So what we needed to do is have the client be as fast as possible so that they can process as fast as possible the people who are entering the country or exiting. And finally, the stress tests for us looked a bit like this. When you have hundreds of people arriving for some reason, they're arriving around the same time, and then your border looks like that. So you want to get throughput of the travelers coming in as fast as possible. So our system, like I said, was the client's Windows WPF application, so pretty old. And then we depended on a lot of devices. I mean, I'm sure if you've been to any border control, you've seen fingerprint scanners, cameras for face recognition, passport readers, signature pads. And then for the next project, you have other models that you have to support because that client wants to have a better quality camera, or they have a better deal with some provider of these devices. And the next project, even more models, and so on and so on. So it becomes kind of difficult to deal with all these different variations of your system. And in terms of technology stack, so I mentioned the front end was .NET. And just to be sure that your development team is really fragmented, and the back end was Java and Linux. So just to make that absolutely sure. So the first problem we encountered was, how do we automate when we depend with these physical devices? We can't control them very well. So one idea is you set up, I don't know how well you can see this, but set up a camera and you put a document in front, and you can manipulate the camera to take a picture and validate if the result is okay. But you can imagine this is not very scalable. This actually was useful to detect memory leak, because we were, with a capture and replay, just taking photo after photo until the application crashed because there was a memory leak. But beyond that, it's not really a great fit for test automation and continuous delivery. So what's the first problem is that these devices have, like I mentioned, very low-level SDKs, and they're all different. Of course, you can't reuse the same calls across devices. So what did we do? There's nothing, no rocket science, just use interfaces. So I won't detail too much about the code. You can ask me later if you have specific questions. But basically, we had, in this example, a fingerprint scanner interface, which defined the actions that made sense for us from our business point of view, our application. And then for each model and each brand, you could have a different implementation of the interface, but you didn't have to know the details when you were developing our application. So this allowed decoupled development. On one side, we had people who were experts at integration with the devices and those low-level SDKs, so they could work on that while other people were working on the logic of the biometric application. So that was a big benefit for development. And why was this important for testing? Because all we had to do is make another implementation of the same interface for this fingerprint scanner, which we call the virtual device, where it's a kind of test double. It's more like an emulator, because the results we got from this virtual device changed depending to what we were testing. I will come back to that later. But essentially, it was just one more implementation. So obviously, for our automated tests, we would use the virtual device implementation. And this also meant to actually be able to get benefits from this was that we need to have a good test data management. So I hope you can see this. Is everyone familiar with BDD, behavior-driven development? Well, it's what you see there, for those who are not familiar, look at it as a test case, where given is the precondition, when is the action, and the then is the result you want to verify. So in this example, for this scenario, we needed to have valid fingerprints. So there are different modes, but normally you can take 4 fingerprints at the same time with one scan. So how did we organize our test data? It was actually just a folder structure. It was a repo, so it was version controlled. But each folder here, like 4 fingers and valid, is a categorization of the test data. And while the data itself are basically images, so those devices, most of them were returning images of the things we needed from them. And with this kind of simple categorization, we could find easily an image with 4 valid fingerprints just by checking that we're getting a file from the folder structure that corresponds to those categories. And then what we would do is the virtual device used the configuration file at runtime, so when the test was executing, to know which image it should return for that call. So this allowed us quite a lot of flexibility in terms of scenarios we could test. So this one is kind of happy pass scenario. Someone wants a visa, and you need to scan the fingerprints, and they're OK, and it gets submitted. And this is more of a narrow case when you were expecting 4 fingerprints and 1 is missing. But we had those test data as well for those error scenarios. And again, it's the same process. We just reconfigure the file that the virtual device reads, and that's the image that's going to be fed to the application that we're testing. So to sum up, this problem was really trying to automate these devices when they're rather simple compared, of course, to the example Stuart was giving, because they just have basic input and image output. So we wanted to get them out of the way. So we defined a common interface for the same class of devices. We do different implementations for each physical model, and then we had a virtual implementation for our testing, and we had categorized test data. So then the next problem we found was that, at least for our applications, the systems for different clients were very similar, right? The the core modules were the same, fingerprints, photo for face recognition, but each client wanted some customizations. Could be at the design level, the colors, the logos, and all that stuff. But also, they usually had some specific requirements. We need this information to be added to the module. And what you end up here, you can see there are 3 different systems, but they look very similar, right? There are small differences. So how can we test all these slightly different systems without duplicating our test code every time and then change for specific things? We didn't want to do that. And again, it's not rocket science. Just get a good layered architecture of our test code to allow for reuse. So the lower layer was really everything that was directly manipulating the interface. So clicking on a button, entering text, all that was down at the bottom level. And by the way, White is a framework for automating, for manipulating the user interface, a bit like Selenium, but for WPF applications and other Windows applications. But you can look at it as Selenium, basically. So we knew that with this low-level automation, everything was there. So when we changed a test and we had new tests for new systems, all the actions at that low level should be there and nowhere else. In the middle, for those modules that we were using across different systems, we again had interface for the expected functionality from those modules. Like with fingerprints, you could capture fingerprints, check if they match, so 2 fingerprints are the same or not. So it's actually the functionality internal to each module. So we have an interface, and we can reuse them across different systems. You can look at it as kind of page object pattern, for those familiar with that, but for our Windows clients. And at the top, now we got to the business logic kind of interfaces. So the methods there mostly corresponded one-to-one to steps in our test cases or scenarios. So again, we could reuse them if different systems had the same test cases or steps. And if they had different ones, most of the time we just add at the top there and do different actions. Sometimes we had to add more when we added a new button, a new text field, we had to change the lower level for the UI automation. But this was pretty good for us. And altogether, this was our test automation framework, and we could avoid a lot of duplication by having this structure. So to sum up here, the problem is reusable modules across different systems with small variations. And with that layered approach, we could solve the problem of not duplicating code all the time, test code. So the final one I'll go through kind of quickly is basically we wanted the ability to use the same scenarios to test different interfaces or different access to the application. So either use the graphical interface, or maybe if we have an API, we wanted to be able to run the same test against the user interface and against the backend and see if we got the results. Or we could have also novice users that are always using the graphical interface, and power users who know shortcuts, the keystrokes to get their work done faster. So those required different automation at the lower level, but we wanted to reuse code at the top level. So we used dependency injection. I'll go a bit faster, but basically at the lower level here, we could implement the actions for the fingerprint module using the graphical interface, and we could do the same, but using keystrokes, sending keystrokes to the application. So, and we just configured for the same scenario here on top, we configured use the graphical interface implementation, and so that would run using that lower level implementation, or switch to shortcuts. And so I don't know, usually we had tags on the scenarios. So we tag this scenario should be run with shortcuts, and this scenario should be run with the user interface, or both. And so we would do different test runs, a test run for all the scenarios with shortcuts, for example. So this allowed that kind of flexibility of testing against different interfaces or different types of usage without duplicating a lot of code, except the lower level where we really needed to do implementation for one kind of interface or usage and another one. So finally, to talk a bit beyond what we did in terms of test automation, which was all what I focused before. Sorry about that. In terms of other things we did in terms of continuous delivery, which was a big thing for me, a big revelation. We had our first build pipeline in Jenkins. This photo is not great, but basically when we had green pipelines for the first time, I tweeted it, and I could tell you everyone was happy ever after, but that's not the truth, as you expect. Soon it would start failing pipelines, and actually not everyone was understanding of the importance of fixing that problem as soon as possible, because culturally we still had some ways to go. So that was a lesson for us. But anyway, in terms of technical terms, what we did as well was we set up our own private cloud for having dynamic resources for the tests, dynamic virtual machines. And we used CloudStack because it seemed the simpler way to set it up, and also it had already a plugin for Vagrant. So our workflow looked a bit like that. The developer would use Vagrant on their local machine, normally with VirtualBox. And once they're happy, they commit, and the CI server does the build. And from then, we go to the automated tests using the private cloud, but also Vagrant. So it was very similar, or normally was the same to execute the tests on the developer machine as on the cloud. And when that didn't happen, when it broke down there, at least we had really quick feedback that something had changed, and it worked for the developer, but it didn't work for our automated tests. So this was what we had initially, and you can see it's not really a pipeline, because if you take out the stuff that is crossed out, you just have one flow there and one flow here, so two different flows asynchronously. But we had unit tests and integration tests running on the CI server directly, which was not great, the integration part. And we would then, a tester would update a workstation, a dedicated workstation, or a static virtual machine, so redeploying the application, and then he would run the automated test and do a lot of manual tests still, to finally end up and say, okay, this is a good candidate release for our clients or not. So that was pretty long. That took very long. And we were able to end up with this, which looked much better, where CI server was only running the unit tests. Actually, that's a typo. I should have changed that first box to unit, not integration. And then the integration tests were already running in instances of CloudStack. And when that was passed, we would run the acceptance tests. And because, like Stuart was saying, this manipulation of the user interface can be quite slow. So the whole test suite would take a few hours. But we could do smoke tests of the main use cases, so that the developers would have faster feedback about if something really serious broke down. And then we would launch all the other tests and get the results later. Of course, there's still a phase at the end where we're doing manual tests and exploratory tests, And at that point, we would use the physical devices, right? Because we don't want to deploy something we never tried with the actual devices. But that phase was much shorter. So overall, the flow was much faster. And one big couple of benefits we got from this, big benefits. One, the deployment and provisioning of the instances that we used for the tests were dynamic and automated and much more repeatable. So we didn't have snowflakes of, oh, this static virtual machine was working and now I redeployed it, doesn't work. And then just fixing it until it works, but you don't really know why. So everything was much cleaner and repeatable. The other, another good benefit was to get rid, we still had in the beginning integration branches, which is just weird, and people were like merging from one branch to another. Now we do integration and release branches, so we simplified that a lot. So we just had we had feature branches, but for the release, there was only one branch you release from. And that's all. Thank you very much for listening.